We are going to create some notes for a special order for graphing both sine and cos when you have all the transformations. You could still do what you normally do for transformations from chapter 3, but the problem with sine and cos graphs, there's 5 important points, and there'd be a lot of math that you'd have to do to all 5 of those. So what we're going to do is we're going to develop a shortcut, and that shortcut I call dab C. Why is it called dab C? Because you actually start with the d value, which is completely different than transformations. But what does your d value do? It moves it up and down. What is the only thing that gets changed by moving things up and down? The sinusoidal axis. So the first thing you're going to draw oh, spelt it wrong. Draw your sinusoidal axes. Now, normally you would have started with A. A is your vertical stretch. What did we know? What did we notice that changed? That changed our amplitude. So whatever we have as a vertical stretch or compression changes our amplitude. And so we know that our amplitude is our A value, so we can use the amplitude to label the max and min values on our y-axis. How does that work? Well, if you know your center line is at 2 and your amplitude is 3, well, you'd go up 3 from 2, your max value would be 5. You'd go down 3 from 2, your min value would be -1. Then we use our B value to calculate the period. And I'll just write the formula here. Our period is 2 pi over B. We'll label that period on the x-axis. And divide it into 4 equal sections. Because our B value is horizontal stretches and compressions. And on our normal sine or cos graph, we have our period and the axis family, which separated into 4 equal sections. When you stretch that or compress that, those sections will still be equal. So if we calculate our period and divide it into 4 equal sections, we'll have done all of those calculations all at once. It's called dab B with a dash on purpose. The dash is important because now you we're going to graph it without the phase shift with a dotted line. So just like we did in, I think it was example 3 of 6.4, where we drew cos first with a dotted line, then we shifted it pi over 6 over to the right. And it was easy because you just sort of can mark where pi over 6 was and shift each of those 5 points just a little bit over. We're going to do the same thing here. And then finally, we get to our C. We're going to translate the graph left or right. Okay? So that's DAB C. Let's look at one example together to see how this works. Graph y equals 3 cos 2. I'll have it in factored form. X minus pi over 4 plus 1. So here's our first graph. According to DAB C, we would start with our d value, which is at 1, and draw our sinusoidal axes at 1. The d value of DAB C is done. Next, we look at our amplitude, which is our a value. Our amplitude is 3, and we use our amplitude to mark our maximum and minimum values. So amplitude is 3. If I go up 3, my maximum will be 4. If I go down 3, my minimum will be at -2. The a part is done. Next, we find our period. Our period is 2 pi divided by our b value. In this case, our period will be, so maybe I'll do it up here, period equals 2 pi divided by our b value, so it's going to be pi. Just pick some random part on your x-axis and label it as pi, and then divide it into 4 equal sections. What's half of pi? Pi over 2. What's half of pi over 2? Pi over 4. What's the third one going to be? 1 pi over 4, 2 pi over 4, 3 pi over 4. The b part is done. The dash. So now we temporarily graph it without the phase shift. So we're graphing a cos graph. Where does a cos graph start? At the maximum. Sine graph starts on the sinusoidal axis going up. Cos graph starts at a maximum. So we're going to start at our maximum. Then each of our axes families, it's going to switch from maximum to center line to minimum to center line to maximum. Dotted line, because this is not our final graph. And then for our final graph, here we have a phase shift of pi over 4 to the right. This is really nice because we've even got pi over 4 marked already. So this point here is going to shift there. This one will shift to here. Shift 1 over, shift 1 over, shift 1 over. Always a 4-mark question on your final exam, because you did 4 transformations. So do you have your center line right? 1 mark. Do you have your amplitude right? 1 mark. Is your period correct? 1 mark. Is your phase shift correct? 1 mark. Oh, I forgot to check off. We did the dash. Now we've done the C, and now we're done. So the nice thing about the shortcut is we don't need to take the 5 individual points that you would have had to begin with. And the 5 individual points would have been like 0, 0, pi over 2 comma 1, pi comma 0, 3 pi over 2 negative 1, and do a whole bunch of math with it. This is going to work out a lot faster and a lot nicer. Do you want to do one more example? We have examples in our notes as well, but do you want to do an extra one? Yeah? Okay. We'll do an extra one, and I'll add a negative out in front to see what that would do. So I'm going to go -4 sine, I'll keep it nice for now, sine 3 x minus pi over x plus pi over 6, switch it up, and -2. So you're going to find in your textbook, if they give you graph paper, you might want to ignore it. Or you might want to graph it first off of their graph paper and then figure out how you'd fit it on their graph paper afterwards. So we're going to start with, put it off to the side here, dab C. Start with my center line at -2, check. What's my amplitude? 4. So even though it's a -4, we always call our amplitude a positive number. Our amplitude is 4, means that we're going to go up 4, 1, 2, 3, 4, to 2, down 4, 1, 2, 3, 4, to -6. So in the dab C, our A value says use that amplitude to find your maximum, find your minimum. Next, our B value. Calculate your period, which is 2 pi divided by your B value, just 2 pi over 3. Mark that somewhere. There we go. That looks like a good spot. And divide it into 4 equal sections. What's half of 2 pi over 3? 1 pi over 3. What's half of pi over 3? Pi over 6. Count by pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6. You okay if I write 3 pi over 6 as pi over 2? So now we've got our period labeled in 4 equal sections, and our B value is done. Next, we temporarily draw our graph with a dotted line without the phase shift. It's a sine graph. Where does a sine graph start? At the center line going up. But it's a negative sine graph. That is a vertical reflection. So instead of going up, a negative sine graph would start at your center line and go down. Does that make sense? If it was a negative cos graph, instead of starting at a maximum, it would start at a minimum. So that's why I added this one. So we're going to go down. That means that your next ticking mark, pi over 6, it's going to be at the minimum. Next one, it's back at the center line. Next one, you're at your maximum. And next one, back at your center line. There's our temporary graph. The dash is done. Finally, we need to do our phase shift. This time we're going pi over 6 to the left. So I need to make a mark to the left. I know that this distance is pi over 6, so does it make sense that negative pi over 6 would be that same distance to the left? And then we take each of these points and shift in that distance over. And we've graphed it, which is pretty impressive looking. because you've accurately put 5 points, and it's got like negative pi over 6, pi over 3, pi over 2. Looks pretty fancy. And it's not bad. The shortcut works really, really well.